Welcome to a world where curiosity knows no bounds and the extraordinary is just a click away.
Born out of the quantum revolution of the early 20th century, a period that saw the birth of quantum mechanics, a theory that dramatically altered our understanding of the microscopic world. Pioneered by some of the greatest minds the world has ever known, this new branch of physics was set to challenge the very foundations of our understanding of reality. Albert Einstein, Niels Bohr, Erwin Schrödinger, and many others. These were the architects of the quantum world. Though Einstein was uncomfortable with the idea of entanglement, famously referring to it as spooky action at a distance, it was his debates with Niels Bohr that pushed the boundaries of quantum theory and led to the discovery of this remarkable phenomenon. Schrödinger, another key player in this saga, was the one who coined the term entanglement. Quantum entanglement, a concept that has intrigued and puzzled scientists for decades, was born from the intellectual clashes of these scientific titans. Today, as we stand on the cusp of a new era of quantum computing, the understanding of this phenomenon becomes ever more crucial. Join us as we dive deeper into the world of quantum entanglement, exploring its mysteries and understanding its implications. Quantum entanglement is a phenomenon that defies our everyday intuition. It's like a mystifying dance where two particles become so intimately linked that they instantaneously mirror each other, irrespective of how far apart they might be. Imagine having two dice. No matter how far apart they are, when one die is rolled and lands on a number, the other die, miraculously, lands on the same number at the same time. This mirroring effect happens instantly, faster than the speed of light, challenging the very fabric of space and time. Now, this isn't about some mystical force connecting the particles. It's about the strange and fascinating rules that govern the quantum world. These entangled particles don't exist in one state or another, but all possible states at once, a concept known as superposition. It's only when we measure one of the particles that both their states become certain. Entangled particles are like cosmic twins, mirroring each other's states no matter the distance. The quantum world is full of surprises. It's like stepping into a fantastical realm where the laws of physics bend and twist in ways that would seem impossible in our everyday reality. In this realm, particles can be in two places at once. They can pop in and out of existence, and they can even influence each other instantaneously over vast distances. This weirdness is exemplified by quantum entanglement. Quantum entanglement is a phenomenon that adds a layer of mystique to the already enigmatic quantum world. It's like two particles are engaged in an intricate ballet, mirroring each other's movements instantaneously, no matter how far apart they are. This isn't a simple interaction like two billiard balls colliding on a table. This is a connection that transcends space and time, a connection that remains unbroken even when the particles are light years apart. But how does this happen? How do these particles know what their partner is doing? The answer lies in the strange rules of the quantum realm. When these particles are created together, they become entangled, their fates forever intertwined. This is not due to some mystical force, but rather the peculiar laws that govern the quantum world, where the line between reality and impossibility is blurred. So, the quantum world, a place where the impossible becomes possible, is the stage on which the mesmerizing dance of quantum entanglement plays out. It's a world that defies our intuition and challenges our understanding of reality. And yet, it's the world that holds the key to the future of technology and our understanding of the universe. To understand quantum entanglement, we must first delve into the quantum world. This is a realm that operates under a different set of rules compared to the classical world we're familiar with. It's the playground of subatomic particles, where the seemingly impossible becomes possible. One of the central tenets of quantum mechanics is the principle of superposition. This suggests that a particle can exist in multiple states at once, only settling on one when observed. It's like a coin spinning in the air, simultaneously heads and tails, only deciding when it lands. Then there's wave-particle duality. It's the mind-bending concept that particles can exhibit properties of both particles and waves. Imagine if you could be both sitting at home and running a marathon at the same time. That's the kind of paradox we're talking about. In the quantum realm, reality is not as it seems. It's a place where the laws of physics as we know them take a back seat, and the extraordinary takes the wheel. Einstein, a genius of his time, initially found himself at odds with the concept of quantum entanglement. Despite his groundbreaking work in physics, the idea of spooky action at a distance was a tough pill to swallow. It went against everything he believed about the deterministic nature of the universe. For Einstein, the idea that two particles could somehow communicate instantaneously over vast distances, faster than light, seemed to violate the very laws of physics. But like all great minds, Einstein was not immune to change. As more and more evidence piled up in support of quantum entanglement, even he had to reconsider his stance. His initial rejection gave way to a reluctant acceptance. He came to realize that the universe might be far stranger than he had ever anticipated. In fact, it was his infamous phrase, "spooky action at a distance," that popularized the concept and brought it into mainstream scientific discussions. Einstein, a genius who was initially baffled by quantum entanglement, eventually came around to accepting this mind-bending phenomenon. His journey from skepticism to acceptance serves as a testament to the ever-evolving nature of scientific understanding. As we delve deeper into the quantum world, we continue to uncover more about this fascinating aspect of reality that once perplexed even the greatest of minds. Einstein famously referred to quantum entanglement as spooky action at a distance, a phrase that captures the essence of the enigma that is quantum entanglement. For Einstein, one of the greatest scientific minds in history, this concept was unsettling. It rattled his belief in a local, deterministic universe where objects affect each other through direct interaction. Quantum entanglement defies this rule. It states that two entangled particles, no matter how distant, can instantly affect each other. Imagine two entangled particles at opposite ends of the universe. Change the state of one, and the other changes instantly, faster than the speed of light. This was Einstein's spooky action at a distance. And yet, despite Einstein's unease, quantum entanglement has proven to be a fundamental aspect of quantum physics. It's an idea that continues to challenge our understanding of the universe, pushing the boundaries of what we thought was possible. Einstein's spooky action is now one of the cornerstones of quantum physics. Now that we've covered the theory and history, let's delve into the practical applications of quantum entanglement. This strange phenomenon, once considered just a quirky aspect of quantum mechanics, has now found its way into the realm of practical science. The most prominent application of quantum entanglement is in the field of quantum computing. Quantum computers use entangled particles, known as qubits, to perform complex calculations at speeds that are exponentially faster than our current computers. The entangled states allow for multiple calculations to be carried out simultaneously, breaking the boundaries of traditional computing. But the potential of quantum entanglement doesn't stop at quantum computing. Scientists are exploring other fascinating applications of this phenomenon. For instance, quantum entanglement could play a significant role in developing ultra-secure communication systems, where eavesdropping could be detected instantly due to the change in the state of the entangled particles. Moreover, it could also contribute to advancements in precision measurements and imaging techniques. And then there's the concept of quantum teleportation, the idea of transmitting quantum information instantaneously across vast distances. Although it's still largely theoretical, the potential applications are mind-blowing. Quantum entanglement, once Einstein's spooky action, could revolutionize the way we understand and utilize technology. Its potential applications are not just exciting, but could change the face of technology as we know it. Experiments have confirmed the reality of quantum entanglement. This statement might seem like a plot from a science fiction novel, but it's the truth. A series of experiments have been conducted over the years to test the validity of quantum entanglement, and the results have been nothing short of astonishing. One of the key experiments that demonstrated entanglement was based on Bell's theorem. Proposed by physicist John Bell in 1964, the theorem was designed to test the predictions of quantum mechanics against those of local realism, a concept Einstein held dear. When Bell's theorem was put to the test, the results were clear. Quantum mechanics won. The particles were indeed entangled, exhibiting correlations that defied the limits of local realism. These experiments and many others have shown us that despite its mind-bending implications, quantum entanglement is not just a theoretical oddity. It is a fundamental feature of the universe we live in. Despite its strangeness, entanglement is a real and proven aspect of our universe. Quantum entanglement doesn't just challenge the laws of physics as we know them, it also forces us to question our very understanding of reality. The idea that two particles can be instantaneously connected across vast distances seems to defy our everyday experience of the world. It's like nothing we encounter in our daily lives, yet it appears to be a fundamental aspect of our universe. This has sparked intense philosophical debates. Some argue that entanglement suggests a deep interconnectedness in the world that goes beyond what we can perceive with our senses. Others suggest that it points to the existence of parallel universes or hidden variables we're yet to discover. Quantum entanglement, a concept that forces us to question our perception of reality, has opened up a Pandora's box of philosophical questions. It's a reminder that the universe is far more mysterious and complex than we could ever have imagined. So, as we delve deeper into the world of quantum computing, let's remember to keep our minds open to the strange and wonderful possibilities that quantum entanglement presents. While quantum entanglement is more than just a fascinating phenomenon, it's also at the heart of a burgeoning field that could revolutionize our world: quantum computing. Picture a computer that works not with bits, but with quantum bits, or qubits. Unlike traditional bits that can be either a 0 or a 1, qubits can exist in both states simultaneously, thanks to a principle called superposition. Now add entanglement into the mix. This allows qubits to be interconnected in a way that measuring the state of one immediately affects the state of another, no matter the distance. This means quantum computers could process information at an exponentially faster rate than their classical counterparts, tackling problems that are currently impossible for our most advanced machines. From disease modeling to climate simulations, the potential applications are mind-boggling. Quantum entanglement could be the key to an entirely new era of computing. Quantum entanglement raises profound philosophical questions. Indeed, it nudges us to reevaluate our understanding of reality and locality. When two particles become entangled, their properties become intertwined, no matter the distance between them. This instantaneous connection challenges the classical concept of locality, the idea that an object is directly influenced only by its immediate surroundings. Furthermore, quantum entanglement pushes us to question the nature of reality itself. According to quantum mechanics, the properties of an entangled pair are not determined until they are measured. This defies the classical view that reality exists independently of our observations. It suggests a much more complex and interconnected universe where the observer plays a significant role. Finally, it raises questions about determinism and randomness. If the properties of entangled particles are truly random until measured, it suggests a universe governed not by strict causality, but by probabilities. Quantum entanglement challenges our deepest held assumptions about the world. The study of quantum entanglement is far from over. In fact, the journey to comprehend this mysterious phenomenon is just beginning. Scientists around the globe are working tirelessly, probing deeper into the fabric of our reality. One of the primary areas of focus is the quest to answer the age-old question of why and how entanglement happens. Does it emerge from some other yet-to-be-discovered principle, or is it a fundamental aspect of the universe? Research is also being conducted to explore if quantum entanglement can be harnessed for practical use. For instance, the field of quantum computing could revolutionize how we process information, and quantum encryption could redefine our understanding of security. Moreover, scientists are venturing to find out if there are limits to entanglement, and what those limits might be. The possibilities are as vast as the universe itself. As we unravel the mysteries of quantum entanglement, we continue to push the boundaries of our understanding. Quantum entanglement is one of the most mysterious and fascinating phenomena in physics. As we've explored, it defies our everyday intuition, connecting particles across vast distances instantaneously. It's the cornerstone of quantum computing, and it challenges our understanding of reality itself. The quantum world is a strange and wonderful place, full of potential for new discoveries and applications. As we delve deeper into the quantum realm, who knows what other wonders we may discover? Now it's your turn to join the conversation. Unleash your curiosity and let your thoughts unravel in the comments below. What do you make of quantum entanglement, this mind-bending phenomenon that defies our everyday understanding of the world? Don't forget to hit subscribe to stay updated on our explorations into quantum physics and a myriad of other intriguing subjects. Share your thoughts on quantum entanglement and its implications for our understanding of reality. We can't wait to hear your quantum musings.